Hello, in this video we're going to discuss complex numbers and solving quadratic equations that have imaginary and complex solutions. The first thing when we're dealing with any sort of polynomial equation is identifying how many answers it's going to have. So let me just start with the fundamental theorem of algebra. The fundamental theorem of algebra tells us that the degree of a polynomial is always the number of solutions it's going to have. So for example, if you have x squared minus 10x plus 125 equals 0, because this is a power of 2, there's going to be 2 solutions. If this is an x cubed, you'd have 3 solutions, and whatever this power is, that's what the fundamental theorem of algebra says. If it was x to the 5th, you'd have 5 solutions. So let's just stick with this problem for a minute and just kind of investigate how this turns out. Something to remember about imaginary and complex numbers is they always come in pairs. I'm going to say imaginary complex solutions come in pairs. So for a quadratic, you're going to have 2 real, 0 imaginary, or 0 real, and 2 imaginary. So those are your options. You can't have 1 and 1. That's not possible. So if you get one imaginary answer, then you also know that you'll have another one. So as you look at a problem like this and you want to start thinking about what kind of answers you're going to have, there's something called the discriminant. Let me just write down the quadratic formula for you first. This is the quadratic formula. The quadratic formula gives you 2 roots of a quadratic equation no matter what. It doesn't matter what the quadratic equation is. It doesn't matter if they're real or imaginary. This works always, no exceptions. So the part under the square root here, this b squared minus 4ac, this is called the discriminant. If b squared minus 4ac is positive, that's positive, say positive, that means this is going to be the square root of a positive number, and the square root of a positive number is a real number. So you're going to have real solutions. If b squared minus 4ac is negative, below 0, because you'd have the square root of a negative number, you're going to have 2 imaginary solutions. And then if b squared minus 4ac is equal to 0, then you have 1 repeated real solution. So we'll talk about that one in a minute. But I want to just start with the quadratic equation I wrote up there at the top and just use the discriminant to decide what type of solutions it might have. So let me just write it again right here. X squared minus 10x plus 125 equals 0. A is 1. B is negative 10. C is 125. So as I look at my discriminant, I'm not doing the quadratic formula, I'm just doing the discriminant. Or b squared is going to be negative 10 squared, and then minus 4 times A times C. That's going to be 100 minus 500. That makes negative 400. And that tells me this has two imaginary or complex answers. Or you could say zeros. That's what I should have said. They're zeros. Numbers that we can plug into this and make it equal 0. So let's just follow through and figure out what those numbers are. And we can also think about the graph here in a moment. So if I want to solve for x, that's going to be negative b plus or minus the square root of, we just found the discriminant was negative 400 over 2 times a. And that is going to be 10 plus or minus, this is going to be the root of 400 times the root of negative 1 over 2. I wrote it like that because the root of 400 is actually just 20. So 10 plus or minus 20i all over 2. I'm going to write those as over 2 individually. And we're going to get 5 plus or minus 10i. Those are my two answers. Those are my two complex number answers. If you were to graph this, because anytime you have complex or imaginary answers, that tells me the graph never crosses the x-axis. If we were to just put this on the graphing calculator real quick and take a look at it, I'm going to push y equals and clear out whatever's in there. X squared minus 10x, x is right here, and then plus 125. And once I zoom standard, once I graph this in the regular window, I'm probably not going to see much because the window needs to be adjusted. So let's just go, let's make this graph really large. And I'll just maybe make the push window. Let's make y go up to like, oh, how about 200, maybe go down to negative 50. We'll count by 50s. And x can go out to like 20 on each side. Just really kind of widen this out. We'll count by 5s there. See what we can see. Sure enough, you can see that graph. It never crosses the x-axis. We could actually go up higher. It doesn't really impact us that much, but we'll just go up a little bit higher. And you can see that graph is completely above the x-axis. The zeros, when I talk about zeros, if they're real, those are the real numbers where we cross the x-axis. So if you were given this graph and someone said, what kind of answers are there, you would know automatically that it's going to be two imaginary or complex answers. So that's kind of the first leap into solving quadratic equations. First of all, we know the fundamental theorem of algebra says that a quadratic equation will have two answers because it has the highest power of x squared. That's called the degree. Second, we can use the discriminant, the b squared minus 4a, the part under the square root. If we look at its sign, that tells us what kind of answers we're going to have. We had a negative discriminant, which meant that we had two imaginary solutions, this option right here. And then we followed through with the quadratic formula and we found all those imaginary solutions. Something also worth mentioning here is the concept of the complex conjugates. And we've mentioned this in the previously, but I just want to kind of write that down. That's 5 plus 10i and 5 minus 10i. Those are called complex conjugates. Conjugates are simply when you have the same items with the opposite sign between them. And when I tell you that imaginary numbers come in pairs, they come in conjugate pairs. They always come like this together. If I said one zero is 5 plus 10i, tell me what the other answer is, you should automatically know that it's going to be 5 minus 10i. So that's just kind of an easy question that you can answer just knowing that imaginary and complex numbers always come in pairs and they come as conjugates. Let's try another one of these. Okay. That one has some relatively small numbers. First off, you know that there's going to be two answers because this is a quadratic equation. It's not written in standard form, so I'm just going to kind of move the minus 2 over by adding 2 to both sides. X squared plus 2x plus 2 equals 0. We're going to identify A, B, C. And let's just start with the discriminant and talk about what kind of answers we expect to see. B squared minus 4ac, that's the part under the square root. And for us, that's going to be 2 squared minus 4 times a times c, which is going to be 4 minus 8. That's negative 4. Just from the discriminant, I know we have two imaginary or complex answers. So let's figure out what those are. X is going to be, we have minus, let's just do my quadratic formula, minus b plus or minus the square root of b squared minus 4ac. We just actually did that already. That was negative 4 all over 2a. This is going to be minus 2 plus or minus root 4 and root negative 1. That's the same as a root negative 4 all over 2. So here we're going to have negative 2 plus or minus, this is 2i. Both of those over 2. So negative 1 plus or minus I. Those are my two answers. So when I do the discriminant, it's actually not any more work because I'm going to have to do it anyway. I'm going to have to do it here. So it's kind of a good like gut check just to know what's coming along. Like I said, if you figure out the discriminant is negative 4, you can just plug it in right there and you don't have to do it twice. Let me just real quickly talk about the graph a little bit more and just show you kind of the three options that we got in the discriminant. I'm just going to write them down again. Two real zeros, z, how about I spell it right? Zeros. Two imaginary zeros. One real repeated 0. So with two real zeros, that is something that you guys probably here. Just kind of draw a graph for each of these. For two real zeros, that could be something like this, where I cross the x-axis 2 times. For two imaginary zeros, that could be something like this. We just saw that. It does not cross the x-axis. It could also be something like this. It could be opening upside down. That's also an example of an imaginary, a quadratic with two imaginary solutions. The repeated 0 is kind of the odd one. That's where we have the vertex of the parabola come down and touch in just one spot. Say this is like a negative 1. That would be simply x plus 1, x plus 1. When you have a repeated 0, that means that you have the same linear factor twice. And if this is equal to 0, you'd say, well, when does x plus 1 equal 0? When does x plus 1 equal 0? They happen to be the same. So if your real zeros ever happen to be the same, that means that the vertex is on the x-axis. It comes down and touches, but then it turns and it goes right back up, or if it's down here, it goes right back down. So those are the three different categories of answers you can get with a quadratic equation. We're going to switch gears and just talk about factoring a little bit with imaginary and complex numbers. Okay. First, we'll start with an example that you've seen before with real numbers. X squared minus 9, this is the difference of two squares. Hopefully you remember that if you have a squared minus b squared, that is a plus b times a minus b. This comes up all the time, so be on the lookout for the difference of two squares. This is going to be x to the second minus 3 to the second, and that simply factors to be x plus 3 and x minus 3. That's easy enough. Imagine you have x squared plus 9. That's the sum of two squares. That's not the difference of two squares. So we need to, just keep in mind there's not a nice formula for this one, like with the difference. But what I'm going to do, I can still factor this. I just have to kind of force it to look like that. So I'm going to start this out as x squared minus negative 9, because two negatives make a positive. And in fact, I'm going to write this as x squared minus negative 9. So it's obvious that you can write x squared as something squared. Negative 9, not so much. So let's just kind of think about negative 9. And if you were to take the square root of x squared, that's just x. But the square root of negative 9 is like the square root of 9, and the square root of negative 1. That's plus and minus 3i. So what you have to do here with x squared plus 9 is you have to rewrite this as x to the second minus 3i to the second. If you were to square the 3, you get 9. If you square the I squared is negative 1, so 9 times negative 1 would be negative 9, and then the negative makes plus 9. This is pretty tricky. This is real tricky, but we're just kind of forcing that positive 9 to be minus negative 9. And once you have this written as the difference of two squares, you can do x plus 3i and x minus 3i. So that's just a kind of a quick way to factor something like this. Another example that involves real numbers, but kind of the same principle. Excuse me. Would be something like this. In fact, I don't have to equal 0 to say x squared plus 10. X squared plus 10 is equal to x to the second. Here, actually, let me do x squared minus 10. Sorry, guys. This is the example of real numbers that I was telling you about. This is like x to the second minus root 10 to the second. So 10 is not a nice square, but root 10 times root 10 is 10. And you could write this as x plus root 10, x minus root 10. And so the same principle kind of applies. It's you forcing this to be a nice square, the difference of two squares. So that's something that you might occasionally see pop up. Let's just solve one or two more equations, and we'll move along. If you have something like 5x squared minus 8x plus 5 equals 0, once again, you can use the discriminant to kind of see what to expect. So a is 5, b is negative 8, c is 5, b squared minus 4ac, b is going to be 64 minus 4 times a times c. That's going to be 64 minus 4 times 5 is 20 times 5, 64 minus 100, negative 36. As you go ahead and apply your full quadratic formula to solve for my zeros here, we're going to have negative b, which is negative 8 or positive 8, plus or minus the square root of negative 36 from up here, all over 2 times a. 8 plus or minus root 36, root negative 1, all over 10. This is 6i, both over 10. So you get 4/5 plus or minus 3/5 I. So just one more example for you before we get to the last topic here for you to practice. There we go. The last topic is factoring just with I. If you have something like x squared plus 1, just one more time thinking about this as the difference of two squares. This is the sum of two squares, but think about this as x minus a negative 1 and x squared minus a negative 1, and that's really x to the second minus, if you take the square root of negative 1, that is I. So it's really just I to the second, that's my negative 1. And this can factor with the difference of two squares, x plus I, x minus I. So just kind of, one last look at, solving a quadratic and factoring the sum of two squares. The thing to remember about quadratic equations, they work the same always, whether you have a complex number or an imaginary number as a root or a real number. The quadratic formula always works. Factoring always works the exact same way. Just because you have numbers with I doesn't mean anything's different. There might be a little bit more legwork to kind of get to where you need to be, but all the principles still work the same. This wraps up our video. You're going to, again, have to practice using the discriminant to figure out if you have two real answers, two imaginary answers, or one repeated real answer. You've got to be able to use the quadratic formula to solve for the roots of any quadratic equation, whether it's got real answers or imaginary answers. Remember, you always have either two real or two imaginary. Because imaginaries have to come in pairs, you can never just have one imaginary answer. If I said this quadratic has one imaginary, how many real answers does it have? The answer has to be 0, because if you have one imaginary answer, that means you've got two. And from the fundamental theorem of algebra, a quadratic equation has two answers. So, there's not any more answers that could be real. Remember, we call those conjugate pairs. Practice these, and that'll wrap this lesson up for today.